Here's another example. So we have an object that's going to explode into 3 pieces. So what we need to recognize, first of all, is initially this thing is not moving. So our momentum, the initial momentum is 0. So our initial momentum is 0. Then we have 3 pieces moving off in different directions. And this question is asking us what's going to happen to this third piece. We know the mass, angle, and speed of the left and the upper piece. But what is happening over here? This is the question. So what is V? And also, what is the angle at which the 6 kilogram piece will move? So just like last time, we're going to create an equation for the x direction, and then the equation for the y. So the initial momentum is 0, so I put 0 there. And then I just look at each of these 3 pieces. So let's define up as positive, right as positive. So first of all, this 9 kilogram object's moving to the left. So it's going to be a negative value. So it's 9.0 kilograms multiplied by 4.0 meters per second. So I can put that negative with 4 or outside, but just make sure you have that one negative there. And it's acting at some cos 38 degrees. And there's also the momentum of the other object, the 6.0 kilogram object, with some velocity v and some angle cos theta. Again, I'm not going to write down that 5 kilogram and 7 point, this 5 kilogram object because it's traveling just in the y direction. So I multiply it through, we get 28.368 kilograms meters per second is equal to 6.0 kilograms v cos theta. So there's our first equation. In the y direction, again, it's initially at rest, then explodes, sending things in different directions. It has that 5 kilogram object, so 5.0 kilograms, multiplied by 7.0 meters per second. And the other 2 objects are both going down, so it's going to be minus the 9.0 kilograms times the 4.0 meters per second sine 38 degrees and minus the 6.0 kilograms multiply v sine theta. And do a little bit of algebra, we end up with 12.836 kilograms meters per second is equal to 6.0 kilograms v sine theta. So here's our second equation. Now we're just going to do a little bit of algebra again, substitution. One shortcut, if you have 2 simple equations like this and there's no plus or minus, what we can do is just divide the 2 equations. So I'm going to call this equation 1 and equation 2. If I divide equation 1 by equation 2, so on the right side we get 6 divided by 6 is 1 that goes away. The v's cancel out, sine over cos, and that's tan theta. On the left side we have that 12.836 divided by 28.368. We end up with 0.4525. Now inverse tan, we end up with an angle of 24 degrees. You can plug that angle into either of the 2 equations again, and we get v is equal to 5.2 meters per second. And we're done. Again, if there's ever only 3 vectors, we can do a triangle method. So what we could have done, same as the previous question as well, look at my 3 vectors. I say, okay, P1, let's just call this 1, 2, and 3. Because there's 0 on the other side, we know these 3 vectors, when added together, must sum to 0. Let's get P1's moving up, P2 down to the left at 38 degrees. That's P2. And P3 is down to the right at that some unknown angle. So basically what we can do is, this is a known angle. We know this angle. That's just going to be 52 degrees. P1 is known, P2 is known. We have an angle between two known lengths. We can say, oh, P3 squared, using the cosine law, is equal to P1 squared plus P2 squared minus 2P1 P2 cos that angle, 52 degrees, just using the cosine law. And that will give us the value for P3, divide by the mass of 6 kilograms. Use sine law, solve for the other angles, and we're done as well.